Let us solve a question on how to find out the level of output where total cost is minimum. The question is, if the total cost function is given by c is equal to 1 upon 2x cube minus 2x square plus 2x plus 75, where x denotes the level of output, we have to find out the level of output where total cost is minimum. Options are being given. We need to find out the correct option. Okay, so let's write what we are being given. We are being given the total cost function is 1 upon 2 x cube minus 2x square plus 2x plus 75. This is our total cost function. If I draw a rough sketch of this graph, and let me try to draw the sketch here. So let us say we have the output on the horizontal axis and total cost on the vertical axis. Okay, since this is a cubic function and its intercept will be, y-intercept is here 75, so it will roughly look like this. That it will look like this, like, okay, this is our total cost function. Okay, now what we need to do here, we need to find out the level of output where total cost is minimum. Okay, so for this first order condition for minimum requires that the first derivative of total cost function should be equal to 0. That means we take the first derivative of the total cost function, that is marginal cost, should be equal to 0, which implies marginal cost is simply the derivative of total cost function with respect to output, and it should be equal to 0. And let's take here the derivative of x cube is 3x square by power function rule, so it becomes 3 upon 2 x, and exponent is subtracted by 1, so it becomes square, minus derivative of x square is 2x, so 2 into 2 is 4x here, 4x plus derivative of x is 1, so we are left with 2, and derivative of a constant is 0. Okay, then we set it equal to 0. Okay, this is the first order condition for minimum. Okay, so this first order condition tells us a point where slope of the function is equal to 0. Okay, here you can see slope of the function is 0 at 2 points, and let's first solve it. Okay, since this is now the quadratic function, let us try to solve this. If we do one thing, if we multiply both sides by 2, what will we get? So we will get 3x square minus 2 4s are 8x plus 4 is equal to 0. Okay, so I have multiplied both sides by 2 so as to remove this denominator here to make it into the standard quadratic form. Okay, so let me see if I have done it correctly. So 2 gets cancelled, 2 4s are 8, 2 2s are 4. Okay, now we can use the quadratic formula to solve this, and let me do that very stuff here. So using quadratic formula, so let us say the coefficient of x square is a, coefficient of x is b, and the coefficient of the constant term is c. Okay, so how do we use the quadratic formula? That tells us x will be equal to minus b plus minus under root of b square minus 4 times a into c divided by twice a. This you know pretty well, it's very basic here. Now give the values to a, b, c here, and let me see if I have the space left here. I don't have, so let me write it here. Okay, so which will be equal, so minus is from the formula, b is here minus 8, so let me write here minus 8 plus minus b square means minus 8 square minus 8 square. Okay, then we have minus 4 times a into c. A is 3, c is 4, so let me write it here 3 and 4. To this we need to divide by 2 times a. What is a? A is 3 here. Okay, let me repeat it again here. First order condition simply tells us the slope should be equal to 0. Okay, so slope can be equal to 0 at 2 points, rather at maximum or minimum. Okay, then we need to apply second order condition to make sure whether we are at the minimum point or maximum point. Okay, now solving this, and let me solve it here. So it is minus into minus is plus, so we will get 8 plus minus. Here we have 8 square is 64, because the square of a negative number is positive, it is 64, minus 4 3s are 12, 4s are 48, divided by 2 3s are 6. Okay, so it becomes 8 plus minus 64 minus 48, so now the kaba, so it is here. So it is here 6, so it is here 16 divided by this step, it becomes 8 plus minus 16 is a perfect square, so it is 4, okay, divided by 6. So also I hope you are getting what I have done here. Okay, so let me write it here. X will be equal to, x is equal to 8 plus minus 4. So we get two values for x, that is either x is equal to 8 plus 4 divided by 6, which is equal to also divided by 6, which is equal to 2. Either we get the value of x is equal to 2 or x is equal to 8 minus 4 divided by 2. Okay, and it gets here 4 divided by, okay, 8 minus 4, 8 minus 4, 8 plus 4, rather here we have 6, sorry, so it is here 6, so 8 minus 4 is 2, so this is here 2 upon 6, 2, rather 4 upon 6, sorry for my weak calculation, 4 upon 6, which is equal to 2 upon 3. So we got two values for x. Okay, and let me now rub this out here. So slope of the total cost function is 0 at 2 points. Okay, when x is equal to 2 upon 3 and when x is equal to 2. Okay, so we don't know which of these two is the minimum point. For that we need to apply the second order condition. Okay, second order condition tells us that we take the second derivative of total cost function and evaluate them at the critical points. Okay, so where is our first order condition? So this is our first order condition. Okay, this is the first order derivative, and let me write it here. So d dc divided by dx is equal to 3 upon 2 x square minus 4x plus 2. This was the first derivative of total cost function. Okay, now second derivative will be equal to d square dc divided by dx square, and let us see what it comes out to be. So taking the second derivative here, exponent becomes coefficient, so 2 will get cancelled with this 2, so we are left with 3x minus derivative of x is 1, so we are left with 4. Okay, and derivative of a constant is 0. So we got this second derivative. Now we need to evaluate it at the critical points when x is equal to 2 and x is equal to 2 upon 3. So when x is equal to 2 in the second derivative, okay, so what will happen? So we have 3 times 2, 3 2s are 6 minus 4, which comes out to be 6 minus 4, which is 2, which is greater than 0. Okay, when the second derivative comes out to be greater than 0, we are at minimum. Okay, and here you can see, and when x is equal to 2 upon 3, let us see what is the second derivative when we evaluate it at this critical point. 2 upon 3, let us see. So we have 3 in Lagunia. So we have 3, x is equal to 2 upon 3, 2 upon 3 minus 4. So 3 gets cancelled, 2 minus 4 is minus 2. Okay, which is less than 0. So this cannot be a minimum point, and this is actually the minimum point. Okay, so first order condition simply tells us the point where the slope is equal to 0, and second order condition tells us if the second order derivative comes out to be positive, we say we are at minimum. If the second order derivative comes out to be negative, we are at maximum. Okay, so at this point you can see we are at slope is equal to 0 and the second derivative is positive. Okay, since it is increasing here, so we can say when x is equal to 2, when the level of output produced is 2 units, we have a total cost minimum. Okay, and let me repeat it here. Second order condition. So second order condition simply tells us if d square dc divided by dx square, when we evaluate it at the critical points, if it comes out to be less than 0, we have a maximum point, and if this d square dc upon dx square, if it comes out to be positive, then we are at minimum. Okay, so the second order derivative is used to test whether we are at minimum or maximum. I hope I make myself clear in this video. So I thank you. I am doing this stuff for free. I don't have any hidden agenda or any other stuff. So this I do for you people. Okay, so if you like these videos, please share with your friends. That will be the motivation for me to keep going on. Okay, thank you.